All right, everybody, welcome back. I hope you all had a good weekend. I hope you're catching up with your work, you're understanding everything, and that just everything is going well for you. So hopefully we only have to do this for a couple more weeks. So please make sure you're telling me if you don't understand something, or if you want to check the answers on your homework, please let me know. All right, we're just going to jump right in with the mental math on page 497. Okay, so remember to pause the video when you need to, or if you need to, and then I'm just going to jump right in. So letter A on page 497 is 70 times 90. What is 70 times 90? Answer 6,300. Okay, so good job on that. Letter B, 364 plus 250. 364 plus 250. The answer, 614. Letter C is 50% of 60. What is 50% of 60? The answer is 30. Letter D, $5 minus 89 cents. What is $5 minus 89 cents? The answer is $4.11. $4.11. Okay, so far so good. Letter E, 100 times 15 thousandths. 100 times 15 thousandths, or 0.015. So the answer to that is 1.5. Remember, that just has to do with moving your decimal over. Letter F is 750 divided by 30. 750 divided by 30. Take a second for that one. The answer is 25. So good job there. Letter G, how many pints are in 2 quarts? How many pints are in 2 quarts? The answer, 4 pints. 4 pints. And then letter H, the favorite, the calculation. So we have 6 times 6 minus 1 divided by 5 times 8 minus 1 divided by 11 times 8 times 2 plus 1, and then find the square root of that. And the answer you should get is 9. Okay, great job. Today we're talking about functions and graphing functions. So at the end of this lesson, hopefully you'll be able to find the rule for a function. Find the rule for a function, I'll tell you what that means. Find a missing number in a function table. Make a table for a function, and graph the function on a coordinate plane. So those are the 4 main things we're going to be talking about today. So first we're going to look at this table, and you'll see the same, not exactly the same looking, but the same information on page 497. So first we're talking about the surface area of a rectangular prism. So if you remember, a rectangular prism is like a 3-dimensional rectangle. So let me draw one of those for you. So surface area is the area of all the faces put together. All of the faces put together. So that's surface area. Now, if you had surface area of a cube, remember a cube is a rectangular prism with 6 square faces. So if you knew the area of one face, how would you find the surface area for the rest of the faces? And so their table is already filled in. So let's fill that in, and let's try to figure out how to go from surface area, or area of one side to surface area of the whole cube. So let's say the area of one side of the cube was 4 square centimeters. What's the entire surface area going to be? Well, we would take that area and multiply it by 6, because there are 6 faces. So if the area of one side of a cube is 4 squared centimeters, then the surface area is going to be 24 squared centimeters, or centimeters squared. So that's what we're filling out here in this chart. If the area of one side of a cube was 9, what would the surface area be? So think about that for a second. If you knew that one of these squares had an area of 9, what would the surface area of the whole cube, so each face combined, and remember this is three-dimensional, so there are some faces we cannot see. All right, so the surface area combined would be 54 squared centimeters. See in the table that they already have those units, so we don't have to write them in the table. Let's say we knew the area of one square was 16. What's the surface area of the cube? The answer to that is 96. And then finally, if one area was 25, what is the surface area altogether? And we would get the answer 150. So what we've just done is filled out a table, and maybe without realizing it, used a rule to solve for that. A rule is basically an equation that applies to this particular function. So a function is a rule for using one number to calculate the other. So what did we do to get from this number? Let's maybe start with a simpler one, 4 to 25. How did we get from 4 to 25? So we took the surface area, excuse me, let me rewrite that one. The surface area equals 6 times the area of each side of the cube. So we took the side of the cube, multiplied it by the 6 faces, and then we got the surface area. So when we're talking about a cube, the surface area, S, equals 6 times A. A represents the area of one side. So this would be called the rule of the function. So basically, this is what we use to solve our problems. So if I give you a new one, if I said on our table, if there was a cube, one square's area was 3, what would the surface area be? We would apply it to this rule. We would use this rule, which is also a function. We've got a couple different names for it here. So we would use this value and plug it in for A, the area. So that means we would do 6 times 3. What's 6 times 3? 18. So if the cube has one area of 3, the whole surface area, every single face of that cube combined, would be 18 square centimeters. Okay? So hopefully that makes sense. So as we go through this lesson, we're going to be writing the rule for different tables and also filling in the table as we go. So let's take a look at our first example. It says find the rule for this function. Use the rule to find the value of m when L equals 7. So basically we're saying, what do we do to L? What do we do to this number in order to get to this number? And one thing that you need to make sure you do before you go and write your equation is make sure it checks out for your other problems. Okay? So how do we get from 5 to 20? What are we doing to 5? Now you might say, if I multiply 5 times 4, I'll get to 20. And that's true. But does that work with the rest of your table? Is 10 times 4 25? Is 15 times 4 30? No, so we might have to think again. What else do you do to get from 5 to 20? And hopefully you'd come up with, you could also just add 15. See if that works to get from 10 to 25. What do? We add 15. To get from 15 to 30, we add 15. So we can write a rule. We can say that I know that whatever L is plus 15 will equal M. Okay? So this is our, maybe I won't use the equal sign just since it's so mathematical. So this is our rule or our function. So we're doing something to our input value to get our output value. We're doing something to get from L to M. So if you're looking along with the example on page 498, you'll see in their chart for one of them, instead of saying on the left it says L, but on the right they changed it. Instead of M, they wrote L plus 15. Okay, so now let's apply this rule to find the function, to find the value of M when L equals 7. So now they're telling us L equals 7. What does M equal? So we're going to take that value and plug it in for L. So we're going to say 7 plus 15 equals M. What does M equal? Okay, and you would get the answer 22. So we did two things here. We found a rule and we found a missing value. Okay, so those are different things, different qualities you're going to have to be able to apply in the future. So determine how you got from your input to your output. That's finding your rule or finding your function. And then also applying that function to find a missing value. So that's why you need to double check to get from L to M. We didn't say, yes, you multiply by 4, 100%, because we checked it against our other values. So hopefully that makes sense. If not, we've got one more example to look at like this. So just hold on. Okay, find the missing number in this function table. So they wrote this one horizontally instead of vertically like we normally look at them. And we have two headings. We have x, and then we have 3x minus 2. Basically what this is telling us to do is to plug x in, whatever the x value is, plug that value into the second part. That would be our function. And then that's how we get our output. Okay, so let's work out this example. 3x minus 2. We're going to say that x equals 2 because that's what this table says. And then we're going to evaluate this problem. So what is 3 times 2? What is 6 minus 2? It's 4, and that's what it says here. So now we have to find what number is supposed to go in this missing box. So I'm gonna write out our function 3x minus 2, and then I'm gonna plug in the value of x, which in this case is 4. So 3 times 4 minus 2. Remember here that you'll need to apply the order of operations. What is 3 times 4? What is 12 minus 2? It's 10. So 10 would be the missing number in this function table. Okay? So hopefully this makes sense. You're either given the function, they gave you the function here, or like our previous problem, we found the function based on going from one value to the next. So you need to be able to apply both of those, and we'll get some practice with that in the practice set. All right, the next thing we're looking at is graphing functions. So hopefully you recall we have something called the coordinate plane, and the coordinate plane is what we use to graph. And remember, we have our x and y values, so remember that's called an ordered pair. And our x-axis is our horizontal, our y-axis is our vertical, so make sure you remember all of these things. Now when you see our table, just like alphabetically, S is going to represent our x numbers, P will be our y numbers. What I mean when I say that is x and y as far as ordered pairs are concerned. So here what we're going to do is we are going to graph this function table on a coordinate plane. We are going to graph this function table on a coordinate plane. So our x value is going to be, basically if you wanted to as well, you could go with each of these pairs and sort of turn it into an ordered pair, so you know this is how you're supposed to be graphing them. So first we're going to graph 1, 4, 1, 4. So remember, you need to locate 1 on your x-axis, that's here, and then 4 on your y. And wherever that is, you'll put a mark. So 1 on your x-axis, 4 on your y. You don't have to copy this table. We're going to do another table, I believe, in just a second. Let me double check. Yes. And you'll have some in your practice set. Just remember that you need to look at your horizontal value first, then your vertical. Okay, so we graphed this point. Let's graph our next 2, 8. So 2 on the x-axis, 8 on the y. Let's put a dot there or a point there. Then we're going to graph 3, 12, and then 4, 16. So those are our 3 points. And next we're going to make sure you use a straight edge for this. You want it to look as nice and neat as possible. And you're going to connect those points. So this particular graph is showing the relationship between the length of the side of a square to its perimeter. So let's think of what the function is for this. We have the side of a square and its perimeter. What's the relationship here? How do we get from the length of one side to the whole perimeter? We multiply by 4. So remember, hopefully you remember this formula from geometric formulas. Perimeter equals 4s. So this is the function that we are graphing over here. Okay, so just take some time to recall how to graph ordered pairs, and that's going to be a great help to you as we go further into this section and further on in math. So remember, you look at your x value first, and then your y value here. Okay? So that one was just an example showing you what to do, and now we're going to actually work through the example in your book. So this is what your book says. It says, the perimeter of an equilateral triangle is a function of the length of its sides. Make a table for this function using side lengths 1, 2, 3, and 4. Then graph the ordered pairs on a coordinate plane. Extend a ray through the points to represent the function for all equilateral triangles. So the first thing you want to do is make a table. S represents the side of this equilateral triangle, and P represents its perimeter. So if you recall from classifying triangles, let me just draw a simple one here. And imagine with me that this is equilateral. It's equilateral to the best of my abilities, honestly. Equilateral, what does that mean? It means all sides are the same length. So if all of these side lengths are 1, what's our perimeter? 3. If all of our side lengths instead were 2, what would my perimeter be? 6, okay? So we can fill in those first two parts. What's the relationship here? What's the function? What's the relationship between the length of the sides and the perimeter of an equilateral triangle? Let's try one more and see if we can figure out what our function is going to be. Let's say the 3 lengths of the sides was going to be 3. The 3 lengths are 3 each. What's the perimeter? 9. So what's the relationship we see here? How do we get from 1 to 3, from 2 to 6, and from 3 to 9? We simply multiply those sides by 3. So the perimeter of an equilateral triangle is 3s. That's our function. That's our function. So then if all of the lengths are 4, what's the perimeter? 12. We just take the length of the side and multiply it by 3. So the first part was filling in that table. The second part is going to be graphing those points. So if you have graph paper, use it. If you don't, you're going to need to be especially particular about making straight lines. So make sure you use a straight edge, or even better, just actually use a ruler. So make a horizontal line. Remember, that represents your x-axis. Make a vertical line to represent your y. And when you make out your tick marks for the different lengths, make sure they line up, excuse me, line up with the lengths of the graph. That's why we use graph paper, to make it nice and neat and orderly. And you also want all of your tick marks to be evenly spaced. So if you see here from the starting point, the origin, I went over 2 lines and made a dash. 2 lines made a dash. So just go and make some lines. And we'll do the same scale here. We'll go 2 lines and make a dash, 2 lines, make a dash. Okay, so make sure you're really particular about these so you have nice, neat, understandable graphs. So S is first. So S is going to be represented on our x-axis. So we're going to do our length of side in parentheses S. And then P represents our y-axis. So we'll call that our perimeter in parentheses P. And now we need to give some values to these points. So you can go by 1s, you can go by 2s. Here, since we went 1 through 4 on the x-axis, I'm going to just go 1 through 4 because that makes the most sense. I maybe made my graph a little too big. And then we go all the way from 3 to 12. So maybe we'll go by 2s. 2, 4, 6, 8, 10, 12, 14. Perfect. Okay. So our first ordered pair is going to be 1, 3. So 1, 3. Because I don't have an actual 3 on my graph, I'm going to go in between, perfectly in between 2 and 4. And then we have 2, 6. So 2, 6. 3, 9. 3, 9. So I'll have to go between 8 and 10 for that one. and then finally 4 and 12. Okay, so that's how you graph those points. You look at your x-axis values first, then your y-axis values. And our final instruction was to extend a ray through those points. So remember, a ray is a type of line segment that has a beginning, and the end has an arrow to show that it keeps going on. So this graph represents the function p equals 3s, which means the perimeter of a triangle in relation to the lengths of the sides of an equilateral triangle. So great job. Hopefully this section made sense. You're looking at the relationships in those tables. We're using those relationships to create graphs. So I'd like for you, if you're not already in your books, you need to turn to page 501. We're going to do the practice set. And I think we're just going to go A through E. So let's do A through E. Perfect. A, B, C, D. So take a second, pause the video, do those problems. Find the missing number in each function table. Those are the problems we're going to do. So what's the relationship to get from one to the other? And make sure you pay attention in letters C and D. They actually give you the function, so you have to plug those values in. So hopefully you just took that time to go over that. It's imperative that you do the practice set because we go over the answers, and I want to make sure that you understand the problem. So for letter A, the missing value is 8. The missing value is 8. So if you're trying to find what the function was in that table, it looks like we were subtracting 2. So you take x, subtract 2, you get y. All right, in letter B, what's the function? What's our missing number? Our missing number is 10. How did we do that? How did we get from A to B? To get from A to B, we would add 5. But what we have here is a missing letter A. So what we need to do is we need to take that value 15 and subtract 5. That's how we got 10. Letter C, they tell you the function is 3x plus 1. That's in the table. So you have to plug in 8. So it would be 3 times 8 plus 1. What would that answer be? 25. And then for letter D, they tell us the function 3x minus 1. So we plug 4 into that, and we get 11. Okay? So I hope that went well for you. I know that was kind of a hefty section. I made your homework a little shorter, so make sure you write down these particular digits. So it starts on page 501, 5, 6, 10, 11, 12, just double checking myself, 22, 25, 26, and 29. So this is all the asterisk problems. The next couple of lessons, it's all the asterisk plot problems and then maybe plus a couple more. So please let me know if you have homework. Please let me know if you have questions, and then don't forget to submit your homework. Either email it to me, email me a picture of your homework, or submit it on Google Classroom. And if you have questions about that, please ask me as well. Okay guys, I hope you're doing well, and I will see you in our next lesson.